So to summarize, like collisions are kind of inevitable, which is like we had these different data types that we saw in the previous video. We had a unique representation of those data types, like which is, let's say if we had, instead of a string, like let's say we had a file and we were to be representing it, we could have represented it using large values which were unique. But the issue again here is that, like, where do we hold that value? Because again, because of the nature of how programming languages are constructed, which is integers hold a finite value, essentially what happens is we get all these overflow errors, which again, like these are not errors, but we have these overflows wrapping of these numbers, which again lead to collisions. So the crux of the problem here, that what we actually saw over the last few videos, is that we had a certain data that we want to store in our data structure, and what we do is we pass this data into something called a hash function, which is what we just covered in the previous set of videos. I explicitly didn't use that terminology, but essentially like converting a string like cat or dog using different ways that we saw were essentially like different hash functions, which essentially what they did was they converted our data into a value. That's the gist of what is a hash function and what is a hash code, which is the value that we get after passing our data into a hash function is called hash code. And this data could be anything, which is integer, string, any user defined data type. In case of, like, if some of you have worked with GitHub, you recognize, like, when we do a commit, we get a hash back, which is like essentially a hash code of what are like a hash code of all the changes that we made into our source code, is like getting generated by passing all the files that we have, which we have coded into this hash function. So essentially, another thing we realized that this hash code that we get can be really large, which is essentially a problem because of the overlapping errors. So all the different functions that we saw earlier, which is like, first we discussed, like, let's say if you have this cat and we use the power of 2 method, we had this transform 2, that's a hash function. We also had the transform 127, which is for ASCII like characters. We can use this function and get this code. If we used for Unicode, we could have a function like this, which is transform 143859. I'm just representing the values, which is the number of characters in a Unicode, to convert this cat into this big number, which again like changes into this number because of overflow. So it kind of wraps around, because this is like 62 billion, but the range of integers is just like 2 billion. So it gets wrapped around to like 1 billion and 956 million and so on. So we recognize, like, if we have, like, let's say if we had this hash function, which is transform 2, this was leading to a lot of collisions, which is we saw that since we have 26 different characters, a lot of characters, because of the pigeonhole principle, will yield a similar hash code, because there are only a finite number of hash codes possible, while the number of characters are a lot more. So essentially this is an example of something called a poor hash function, because it is generating the same hash code for like similar values. And because of the limitations of language, what we saw was these larger functions, like if we get a very large number, it still resulted in collision. So no matter what we do, we are essentially getting a collision. So how we can fix that is what we are going to see now, which is we have these two big problems. First is we have like collisions, as we discussed just now, and the second one is if we use like larger values, we are wasting a lot of memory, because a lot of memories are essentially not required, but we still have to define them. So to solve this, these are some of the things that we are going to do. The first thing is we are going to accept the fact that there will be collisions no matter what we do, because they are like trade-offs here. So We would allow the collisions, but we would use different collision resolution strategies, which we are going to discuss today, which is we are going to just discuss two of them, the most two common ones, but there are a lot of them outside of the scope of the course, or even if you read the book, there might be like more strategies that you can use. The second strategy that we are going to use is we are going to start initializing our table with a smaller size, which is when we define our array to be of smaller size, and as we are inserting new values, we are going to define like a new factor, which is called like load factor, or a new metric, which essentially states that, like, let's say if a hash table size is 100 and there are 50 values in this table, so load factor essentially tells us how filled is our hash table, which is if there are 50 values and it can store up to 100 values, we know like it's full up to like 50%. So what we are going to do is we are going to use this new metric to alter the structure of our table as we try to insert like new values. So those are the two big things that we are going to see now. So the first one, which is like to reduce the size of, like, let's say if we get a hash code, which is what we saw earlier, which is we have this data, we pass into this hash function, we get a hash code. Now the issue is, now we might have a smaller size of the table, which is like, let's say when we are trying to address this, we are creating deliberately a small size of the table, which is like initially we defined the size of the table as 10. So we have this additional function here that's called reduce function. And the purpose of this function is to reduce the hash code to an index, which is like, let's say if this table has a size of 10, what we can do is we can use a very simple reduce function, which is you just use mod 10 to convert your hash code. Like, let's say if our hash code is 214 million or something, we can convert this by using this table size, because we have stuck this table size or defined this preemptively. We can reduce this table size into an index, because we know that they are going to be collisions no matter what, which is, we know that, like, let's say if we have 2145, this will have an index 2. If it is 22, this will also have an index 2. So we are going to store these values like 21452, like sorry, 22. All of these will be in the same bin, which is the second position. And how we are going to handle these collisions, we are going to see very shortly. But essentially, we insert the data at the index in the table. If there is some other data at, like, first we try to insert the data at the index, which is for this 2145 value. If I do 2145 mod 10, I think I earlier generated like 2, which is wrong, because it should actually result in 5. So 2145 mod 10 is 5. So at the 5th index, I'm going to store 2145. And now if I have another value like 25, if I do 25 mod 10, like based on my hash code, which is my hash code is 25. So 25 mod 10 will also yield the index 5. So what I'm going to do is I'm going to check if a value exists at index 5, which there is a value. So in that case, what we are going to do is we are going to adopt to our collision resolution strategy, okay, which we are going to define very soon. They are different ones. So based on how you implement, you are going to adopt that strategy, which is you can't directly actually insert. First, you have to check if there is a value existing there. And since we know that there is bound to be collisions, you'll have to match whether 25 is this number or not. Because if this is this number, if this number was already 25, then you don't do anything, which is you just skip, because we know in a set or a map data structure, if you have the same key again, you just don't do anything, or you overwrite the existing value. So let's discuss the components of all of this, which is the remaining part of the lecture will focus on two things. One is the components of this flow, which is what is a hash function, what is a reducer, what are those functions, and then we'll discuss the collision resolution strategies, and we'll discuss all of this in the light of what would be the time complexities of these operations. So we'll start discussing hash functions in the next video, and in the video after that we'll discuss the other aspects of hash tables. Thank you.